The function f from x to y is denoted as f from x to y is called as a function, denoted as f from x to y as a function. The element y belongs to y is called as the image of the element x belongs to x. So if f from a to b is a function or a mapping from a to b, then the set A is called as the domain of the function and the set B is called as the codomain. The function f from a to b is called many one function means if different elements of the set have the same images in B. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss the very important part, that is called the functions and the types of functions and the problems based on types of functions. Now let us come to the definition of a function. Now let us consider what is the definition of a function. Now let us consider two non-empty sets. Suppose if x and y are any two non-empty sets, let x and y are any two non-empty sets, then A is the subset of x and y. Suppose if x and y are any two non-empty sets, let x and y are any two non-empty sets, and if A is the subset of this x as y, that is the Cartesian product of x and y. Suppose if x into y is the Cartesian product and if A is the subset of this x plus y, is called as a function. A is called the function if and only if the following conditions are satisfied. What are the following conditions? For every x belongs to x, for every element x belongs to capital X, there exists a unique element y belongs to y. So there is a unique association. For every element x belongs to x, there exists an unique element y belongs to y such that x comma y belongs to f. And also element of x, the first element of set x should not be repeated, means it should not be used more than one time. The first element of the set should not be repeated, should not be used more than one time. So if these two conditions are satisfied, then f from x to y is called a function. So the function f from x to y is denoted as f from x to y is called as a function, denoted as f from x to y as a function. Now let us consider, for example, if a set A contains A, B, C, another set B contains 1, 2, 3, then the function f from A to B is denoted as f from A to B is a function. Now suppose if these conditions are satisfied, let us consider the sets A and B. What are the elements of A? A contains A, B, C and B contains 1, 2 and 3. Let us map 1 to 2, B to 1 and C to 3. Now let us write the elements. What are the elements? Function of A, f of A. So f of A is equal to 2 and f of B is equal to 1, f of B is equal to 1 and f of C is equal to 3. So here, that is the element A, each and every element of the set A is associated with a unique element of the set B. See, A is associated with 2 and B is associated with 1 and C is associated with 3. So each and every element of the set A is associated by a unique time with the element B of the element B. That means if x belongs to x, then there exists unique element y belongs to y such that f of x comma y is equal to f. Further, element of x should not be repeated. That means the any element of the set A should not be repeated. See, here there is 1 to 2, B to 1 and C to 2. So therefore, f from A to B is called as a function. This is the definition for a function. Hope you got an idea. So a function is defined for every x belongs to x. There exists a unique element y belongs to y such that x comma y belongs to f. Further, the element x should not be repeated. Next, let us take a small example. Now, before going to example, let us know some properties. Suppose if x1 comma y1 belongs to f and x2 comma y2 belongs to f, then y1 is equal to y2. So if y belongs to y is called the image of the element x under x. So y is called the image. The element y belongs to y is called as the image of the element x belongs to x. So suppose if A and B are any two sets, A contains A, B, this is 1, 2, 1, this is the mapping. If these are the mapping, then the element y belongs to set y is called as the image of x. So This 1 is the image of B and 2 is the image of A. So the image of 1 is B and similarly the image of 2 is A. So y belongs to y is called as the image of the element x under x belongs to capital X. Now x is called as the pre-image. This A and B are called as the pre-images. A and B are called as the A and B, that is A comma B are called as the pre-images. Pre-images. X is called as the pre-images and the set X is called as the domain of the function. The set X is called as the domain of the function and the set Y is called as the range of the function. So the set X is called as the domain and the set Y is called as the range of the function. See here. So if y belongs to y is called the y belongs to y, that means y belongs to the second set is called as the image of element x belongs to x. That means these are called the images of the elements A and B. And therefore this x is called as the pre-image of y. X is called the pre-image and the set x is called as the domain of the function, and whereas the set B, the set y is called as the range of the function. So the set of all elements x is called as the domain of the function and the set y is called as the range of the function. Now let us consider one small example. If A is equal to the elements of set A is 1, 2, 3, B contains A, B, C, and let the function is defined by f is equal to 1 comma A, 2 comma B and 3 comma C. Now let us verify whether this is a function or not by indicating through an arrow diagram. Now let us represent what is given here. A is equal to the elements of set A is 1 comma 2 comma 3. Another set B is given, B is equal to A comma B comma C. And write down the elements of the set A and B. So this is A and B. This is a function. F from A to B is a function or not, we have to verify by drawing through an arrow diagram. So A contains 1, 2 and 3. A, B, C. What is given? This is given. F of F is given to be 1 comma A, then 2 comma B and 3 comma C. See here, 1 to A, the mapping is from 1 to A. Again 2 to B, 2 to B is mapped. Again 3 to C. So here all the elements of A have the unique association with the elements of the set B, and no element of A is used more than one time. So therefore F from A to B is a function. F from A to B is a function. Therefore F from A to B is called a function. The set of all first elements. So therefore the domain of this function is domain of F. Domain of the function f is equal to set of all first elements, that is 1, 2 and 3. And whereas the range of this function f is equal to range of the function f is equal to A comma B comma C. That is the range. So therefore these are called the images. A, B, C are called the images for this. Right. That is what we have explained here. So that is y is called the image of x. So A, B, C are the images of 1, 2 and 3. So the set of all, the set x is called as the domain, the set x is called as the domain of the function, and the set y is called as the range of the function. So this is a function from A to B. That's it. Okay. Let us take one more example. Example number 2. Let if A is equal to A contains 2, 3 and 4. B contains 4 comma 5. Let us write the map. F is equal to the mapping is 2 comma 4, 2 comma 5, 3 comma 4, 3 comma 5. Check whether this is a function or not. Now let us write the elements of the set A and B. A and B. What is A contains? 2, 3 and 4. What is B contains? 4 and 5. Now check whether f from A to B is a function or not. Let us draw the diagram. So here arrow diagram. What is the map function given? 2 to 4. 2 to 4 is a mapping. Again 2 to 5 it is a mapping. Again 3 to 4 they have given. Again 3 to 5. 3 to 5. So here since the element 2 and 3 of the first set, the element 2 is used 2 times and the element 3 is also used 3 times. So here 2 is used 2 times and 3 is also used 2 times. So therefore this is not a function from A to B. So f from A to B is not a function. This is not a function. So according to the definition, there is a unique association. the first element should not be used more than one time. Here the element 2 is used more than one time, 2 times. Similarly, element 3 is also used. So therefore f from a to b is not a function. That's it. Now let us come to the domain, codomain and range of a function. As I already explained, the domain, codomain and the range. Let us consider a function f from a to b. That f from a to b is a function, that is f from a to b is a function of a mapping. Then the set A is called as the domain of the function and the set B is called as the codomain of the function. So if f from a to b is a function or a mapping from a to b, then the set A is called as the domain of the function and the set B is called as the codomain. A is the domain and B is the codomain. The set consisting of all the images is called as the range of the function, which is denoted as f of a. It is written as f of a. So the range, the set consisting of all the images is called the range of the function f, which is denoted as f of a is called the range. So the set of all first elements, that is a of the function is called the domain. The set of all elements b of the function is called the codomain, and the images of the f is called as the range and it is denoted as f of a. Now let us consider an example. If f is equal to, the function is given. So f is equal to 1 comma a, 2 comma b, 3 comma c, 4 comma d. Now so here what are the elements, what is the function given? Let us write down this set represent in a diagram a and b. So a contains 1, 2, 3, 4. Another set b contains a, b, c, d. Then what is the mapping given? So 1 to a is given. Again 2 to b it is mapped. 3 to c they have given. 4 to d. This is the function from a to b. All the elements of a is used, and further there is a unique association. No element of a has used more than one time. So now let us write down the domain of the function. Domain of a is nothing but the set of first elements 1, 2, 3, 4 is called the domain. The set of all elements, of the function is called as the domain. That is 1, 2, 3, 4 is called the domain. Similarly, what is the codomain? Codomain of f is nothing but the set of all second elements of the function. That is nothing but a, b, c, d. This is called as the codomain. This is domain and this is codomain. Further, the elements of the set B is called the codomain. Further, the range of f is nothing but the images. The images of f is called as the is called the range. So what is the range? A, B, C, D is called as the range. So here the domain is 1, 2, 3, 4 and the codomain is A, B, C, D and the range is also A, B, C, D. The images is called the codomain. This is called the range. So this is how we are going to find the domain, codomain and range for a given function. This is very, very important concept indeed. Okay. Now let us know regarding different types of functions. Different types of functions. In the first one is into function. So the mapping f from a to b is called an into function if there is at least one element of the set B which is not an image. At least one element in the set B which is not an image. So or which has no pre-image, and it is denoted as, symbolically we write f from a to b as a into function. See here, the mapping f from a to b is called as an into function if there is at least one element in the set B which is not an image. That means at least one element of the set B is not used. That's it. Such a function is called an into function. Now let us take for example. Let us write an example. If a is equal to 1, 2, 3, 4, another set B is equal to A, B, C, D and E. A map function is given. F is equal to 1 comma B, 2 comma C, 3 comma A, 4 comma E. Now let us write the mapping here. This is A and B. F from A to B is a function. Since what are the elements of A? A contains 1, 2, 3, 4. B contains A, B, C, D and E. What is the mapping given? 1 to B it is given. Again 2 to C. This is 2 to C. 3 to A and 4 to E. So here the element D is not used. the element D is not used here. That means the element D, at least one of the element of the set T which is not an image. So there is this element D is not an image. So therefore this is called an into function. This is an example for an into function. So into function means a function f from A to B is called an into function if there exists at least one element of the set B which is not the image of any element of X. So that is, here D is not an image for any element. So therefore this is an example for an into function. Okay. Now let us come to the second one, many one function. Many one function. A function f from A to B is called many one function means if different elements of the set have the same images in B. Let us take an example. Let A is equal to A contains 1, 2, 3, 4. Another set B contains B is equal to A comma B. Then the function is given by f is equal to 1 to A, 1 comma A, 2 comma A, again 3 comma A and 4 comma B. Here, that is here, what is A? A and B are the sets, A and B. Check whether it is a function or not. A contains 1, 2, 3, 4. B contains A and B. Mapping 1 to A, again 2 to A, 2 to A, again 3 to A, 3 to A, and again 4 to B. See here, that is many one function if different elements of the set A have the same image. See here, the different element, the element 1, 2 and 3 of the set A has the same image A. So that means this is called an example for a many one function. Many one function. Different elements of the set A have the same image. Different elements of the set A have the same image in the set B. So the image of A is 1, image of A is 2, image of A is also 3. So that is why this is called an example for a many one function. Let us take one more example. Let us write 1 minus 1, 2 minus 2. Okay. Set A contains 1 minus 1 and the set minus 1, B contains 2 minus 2. Then here this is 1 comma 4. So let us map like this 1 comma 1 to 1 minus 1 to 1, again 2 to 4 and minus 2 to 4. So here the element 1 will have the same different images 1 and minus 1. Here also the element 4 has the different images 2 and minus 2. Therefore f from A to B, f from A to B is called as a many one function. Many one function. So many one function means the element 1 has different images in the set A. Okay, that is 1 and minus 1. 4 will also the images 2 and minus 2. This is an example for many one function. Now let us come to the next type function, one function, or it is also called as the injective mapping. Very important it is. A function f from A to B is said to be one function if different elements of the set A have the different images in the set B. Different elements of A has different images in the set B means then it is called as a one function. Symbolically, we can represent f of x1 is equal to f of x2 implies x1 is equal to x2 for all x1 comma x2 belongs to the set A. If for all x1 and x2 different elements x1 comma x2 belongs to A, if f of x1 is equal to f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is called one function, or it is also called as a injective mapping. It is also called as injective function. So a function f from A to B is said to be a one function if different elements of the set A have different images. That is, if for all x1 comma x2 belongs to the set A, f of x1 is equal to f of x2 implies x1 is equal to x2, then f of x is called an one function. It is called an one function. Now let us come to onto function, or it is also called as the surjective function. Surjective function means a mapping f from A to B is called an onto if every element of the set B is the image of some element of the set A. If every element of the set B is an image of some elements of the set A, then it is called an onto function. Now let us consider, for example, if f of x is equal to x square for all x belongs to n, the natural number which is less than or equal to 3. So what is given? F of x is equal to x square. the set of natural numbers less than 3 is 1, 2 and 3, less than or equal to 3. So f of 1 square is equal to 1. Similarly, f of 2, that is nothing but 2 square is equal to 4, and f of 3, 3 square is equal to 9. So here this is a mapping. Every element of the set B is the image of some element under A. See, this is, what is A? A is 1, 2, 3 and B contains 1, 4 and 9. So that is 1, f of 1 is 1, f of 2 is 4, f of 3 is equal to 9. Okay. So this is an example for a onto function, because here what is A? This is A and this is B, this is function. So f of 1 is equal to 1, f of 2 is equal to 4, f of 3 is equal to 9. That's it. Now let us come to the next type, that is bijection or bijective function. Bijection, or it is also called as 1, 1 and onto function. Bijective function, bijection or 1, 1 and onto function. So here itself this 1, 1 and onto itself is called the bijective. That means a function which is both 1, 1 and onto is called as a bijective function. A function f from A to B is said to be a bijective function if f is both 1, 1 and onto function. A function f which is both 1, 1 and onto is called as a bijective function. Very important, they may ask for definition of bijective for 1 marks. So a function f from A to B is said to be a bijective function if f is both 1, 1 and onto function. 1, 1 and onto function. Now let us take an example. If A is equal to 1, 2, 3, 4. Another set B contains B is equal to P, Q, R, S. Okay, what is the function given? The map is given. So write down here. This is F and A and B. What are the elements of A? 1, 2, 3, P. B contains P, Q, R, S. Now what is the map given? F of 1 is equal to P, F of 1 is equal to P, F of 3 is equal to R, F of 3 is equal to R, F of 2 is equal to Q and F of 4 is equal to S. So therefore this F from A to B is both 1, 1 and onto function. So a function which is both 1, 1 and onto is called a bijective function. So f from A to B is both 1, 1 and onto function. Therefore this is a bijective function. Very important concept. Next, let us come to the next type, 1, 1 into mapping. 1, 1 into mapping. So a function f from A to B is said to be 1, 1 into function if the range of the function is a subset of B. If the range of the function, is subset of B, means then f from A to B is said to be 1, 1 into function. That is, f of x1 is equal to f of x2 implies x1 is equal to x2. That means there must be at least one element of the set B which is not the image of the some elements of set A. So let us consider, for example, if f of A is 1, f of 2 is B, f of C is equal to 3. Now let us consider an example. If A is equal to, A contains 1, 2, 3 and B contains A, B, C, D. Let us consider an example. If A is equal to 1, 2, 3, B is equal to A, B, C, D. Now let us write the function. This is A and B. F from A to B is a function. What are the elements? 1, 2 and 3. Here A, B, C, D. What is the mapping given? F of 1 is equal to A, f of B is equal to 2 and f of 3 is equal to C. Yes, here the element D belongs to B, D belongs to B, which is not the image of any element of A. So therefore this is an example for a 1, 1 into function. 1, 1 into function. That means a function f from A to B is said to be 1, 1 into function if the range of f is a function of the subset. That means there must be at least one element B which is not the image of some element of the set A. That's it. Okay. Let us come to the next one. Many one onto function. Many one onto function. A mapping f from A to B is said to be many one onto function if range of the function is equal to B. If the range of the function is equal to B and further f of x1 is equal to f of x2 implies x1 is not equal to x2. If f of x1 is equal to f of x2 implies x1 is not equal to x2, then and the range of the function is equal to B, then it is called a many one function. That means two or more elements of the set A has the same image in the set B. Two or more elements of the set A will have the same image in the set B. Such a function is called many one on two function. Many one on two function. So, suppose if f of minus 1 is 1, f of 1 is also 1. F of minus 2 is 2, f of minus 2 is 4, f of 2 is also equal to 4. This is an example for a many one on two function. See here, what are the elements we have? So, A contains, see these are the two sets. Here A and B, A contains 1, minus 1, 2, minus 2. Here it is 1 and 4. So, what is the map here? 1 to 1, minus 1 to 1, 1 to 1, minus 1 to 1. Again, f of minus 2 is 4, f of plus 2 is also 4. Right. This is an example for a many one on two function. That means here the range of the function is equal to B. Further, two or more elements of the set A have the same image. So, the set 1 and minus 1 have the same image, and 2 and minus 2 will have the same image. That means here x1 is not equal to x2. See here, if you take x1 is equal to 1, x2 is equal to minus 1, f of x1 is equal to f of x2. That is, if you take function f of x is equal to x square. So, this is 1 square minus 1 square. 1 is equal to 1. So, different elements will have the same images. So, x1 is equal to 1 and x2 is equal to minus 2. That means x1 is not equal to x2, implies f of x1 is equal to f of x2. F of x1 is equal to f of x2 when x1 is not equal to x2. So, 1 and minus 1 will have the same image, 2 and minus 2 will have the same. So, therefore, this is an example for a many one on two function. Okay. Now, let us come to the next concept, constant function. Constant function. So, constant function means f of x is equal to k here. See here, let f from a to b is a function where f of x is equal to k for all x belongs to a and k belongs to b. F from a to b and f of x is equal to k for all x belongs to set A and k belongs to set B. That is, if each and every element of A belongs to A, is mapped onto a single element k of the codomain. That means, if each and every element of the set A is mapped to a single element of the codomain k of the set B, then it is called as a constant function. So, that is denoted as a constant function is nothing but f of x is equal to k for all x belongs to A. For all x belongs to A is called as a constant function. Now, let us take for example, f of 1 is equal to k, f of 2 is equal to k and f of 3 is equal to k is an example for a constant function. That is, here see here. Suppose if I map this, A contains 1, 2, 3 and k, this is the function A to B, that is 1 to k, again 2 to k and 3 to k. So, therefore, this is a constant function. Next one is the inverse function. Inverse function. Let f from a to b is a 1, 1 and on to function from a to b, then each b belongs to a, for each belongs to a, f inverse b belongs to a, exists a unique so that f inverse from b to a is a function defined by f inverse of b is equal to a, if and only if f of f is equal to a is called an inverse function. So, if it is bijective function, f inverse is also a bijective function. So, a function f from a to b is 1, 1 and on to function, then only it is an invertible function. So, the inverse of f is denoted as f of b. The inverse of this is nothing but f inverse b. F inverse of b belongs to a, exists and unique so that f inverse from b to a is a function. So, if f from a to b is 1, 1 and on to function, then the function from b to a is called the inverse, that is denoted as f inverse of b to a. So, if f is both 1, 1 and on to, then only then it is called an invertible function. That is, if it is a bijective, then only it is an invertible function. Say for example, if this is a and b, so a contains this a and b, this is the function f and this is called the invertible function f inverse. A to b is the function B to A is called as an invertible function. That's it. Okay. Let us come to the next one. A composition of functions. Composition of functions. So let us consider A, B and C be any three non-empty sets. Let A, comma B, comma C be any three non-empty sets, and let F from A to B and G from B to C be any two functions. So if F from A to B and G from B to C are any two functions for any three non-empty sets A, B, C, then we define the composition of function as G naught F or F naught G. Gof G naught F from A to C as G of F of A is equal to G of F of A for all A belongs to A. Since F of A belongs to B and G of F of A also belongs to C, thus G naught F so obtained is called as the composition of the function F and G. Similarly, we can define the composition of F naught G as F of G of X. Now, let us represent how many sets are there. Let A, B and C are three sets. A, B and C are three sets. This is A, B and C. Okay. A, B, C are three sets. Three non-empty sets. So, let us contain A, here F of A. So, this is a function from A to B. F of A is a function. Okay. Now, let us consider G. So, G is a function from this. This is G of F of A. The function from A to C, this is called as the A to C is called G naught F, Gof, that is denoted as G naught F of A is equal to G of F of A for all A belongs to A, for all A belongs to A. So, that is G naught F of A is equal to G naught F of A is equal to G of F of A for all A belongs to A is called the composition of the function. So, therefore, G naught F of A is equal to G of F of A, or similarly F naught G of A can also be written as F of G of A. This is called the composition of a function. So, a function A to A, B, C are three non-empty sets, then A function from A to B is F of A, and again function from B to C is G of F of A. That's nothing but G naught F of A is a function from A to C, that is called the composition of the function here. Now, let us take the last definition, identity function. Identity function. A function F from A to B is said to be an identity function if F of X is equal to X for all X belongs to A, and symbolically we are going to represent an identity function IA, that is IA from A to A is called an identity function. So, for example, let us consider for example, if A and B contains, A contains 1, 2, 3, B contains 1, 2, 3, 1 to 1, 2 to 2 and 3 to 3. This is an example for an identity function. That's it. A function from A to A is said to be identity function if F of X is equal to X itself. Function of 1 is 1, function of 2, F of 1 is equal to 1, F of 2 is also equal to 2, F of 3 is also equal to 3. F of X is equal to X for all X belongs to A is called an identity function. We are going to represent it as an IA, identity function from A to A. A to A is called an identity function. If F of X is equal to X, then it is called an identity function denoted as I of A. That's it. Okay. Hope you follow. So, these are all different types of function definition and types of functions and the examples for this. Hope you followed this. These are all basic concepts of types of functions. That's all regarding today's session. Let us meet with the different concept in the next session. Thank you. Thank you very much.